Let's talk about the other keyword that goes along with new, which is called delete. Now, remember that the new keyword will ask for a new spot in memory, a new block of memory, right? So if here's my memory bank, here's my RAM, and I ask for a new block of memory here using the new keyword, something that looks like this, new int, right? And it gives me this little spot in memory to store an integer. Now, there's no variable associated with this or anything, right? And this is actually a line of code that you would probably never write. You would always want to assign this back to a pointer so that you sort of hold on to that value. I'll do that right now for argument's sake. So say I have a pointer p, which is pointing to my new block of memory that's holding my integer, right? So one important thing to note is that if you are writing a function, whatever it may be, it could be an if statement, it could be a function, whenever you have these curly braces, you're creating what's called scope. And when you declare a variable in here, if I say int a equals 5, a has local scope to this block. And in fact, in C++, when I hit this close brace, it's going to automatically delete this spot in memory. So I can't access it anymore. So as an example, just to show you what I mean, if I were to execute a block of code that looks like this, now this could be an if statement, it could be a function, it could literally just be curly braces inside of a larger function, right? You can just add these to create scope. When I execute these lines of code, it's going to create a new spot in memory for A. It's going to put the value 5 in that block of memory, right? Then it's going to hit this curly brace here at the bottom. And when it hits that, it's going to delete A, which is going to free the block of memory, right? So there's some keywords that I'm using here. Allocate a block of memory, free a block of memory, right? These are terms and phrases that we are going to use continually and that you should learn the proper nomenclature. It's going to free up this variable A. This means that after this scope, if I try and do something like this, a is equal to 4, this is going to give me an error. In fact, in Visual Studio, it's going to put one of those little red squiggly lines under it saying, hey, you can't access A anymore because it doesn't exist in this context. You probably will get some error like that saying this thing doesn't exist, right? And the reason why is because A has local scope. Now, one thing to think about. What if what I'm declaring in here isn't just a plain old variable A? What if what I'm declaring here is something that looks like this? An integer pointer p equal to a newly allocated block of memory for an integer. All right, this exercise is really important. So if this may be a section that you might want to watch over and over and over again just to kind of get what's going on here, right? And it's incredibly important that we know exactly when to use this delete operator, especially when we're using the new operator. So here it comes. This line of code, what does it do? It does a couple things. First, it allocates a new spot in memory for an integer. Let's go ahead and do that. Here's a spot in memory for an integer. There's no variable name associated with it. It's sort of like an anonymous space in memory, right? Let's give this the memory address 0x ABC123. Let's just pretend it has that memory address, right? The second thing that it does, it creates this, the integer pointer p. Here is my variable p, which is at some other spot in memory. I'm not even going to bother writing the memory address of it because we don't need to be concerned about it. This p variable holds an integer address. It's a pointer to an integer, and it's going to hold the address of this integer that I've requested. Remember that the new operator returns back a memory address. So the value in p is going to be 0xabc123, right? Now here's the important thing. Remember before, when I hit this close scope and it removed that variable a, right? It cleared it from memory automatically. When I hit this close brace here and this loses scope, what do you think the computer is going to get rid of automatically? What do you think it's going to get rid of in C++ automatically? Well, it's going to get rid of anything that's been declared here on the stack. This is the difference between the stack and the heap. And if you want some more explanation about stack and heap, I'm happy to go into it. Here, it's going to remove this, the variable that has been declared in this scope, the integer star p. It's going to remove this variable and this block of memory. And that's it. Now notice what's happened. once we've gone beyond the scope here, this variable remains. This is still taking up space. This is what is called a memory leak. For every program that you're running, if you open up Task Manager and you look at how much space is taking up in your RAM, how much memory, and you see that programs are running, and the longer they run, the more and more memory they take up, this is why. It's bad programmers forgetting to delete their stuff in memory. So what do? How do we account for it? We need to use this delete keyword. The rule of thumb is whenever you use new, you must use delete. Whenever you allocate memory, you must deallocate it or free that memory, right? Whenever you use new, you must use delete. So let's add one more line of code to actually make this thing work properly. We're going to call the delete operation. The delete keyword takes a memory address. Well, we have a memory address. It's P, right? Not asterisk P. We don't need to deallocate P, right? We're not looking at the value of in this integer. It's just P. P holds the memory address of what it is that we want to delete. By doing this, when we hit the bottom here, the delete P command is going to go ahead and free up this space. It's going to deallocate it, right? Then, when this thing loses scope, P will also go away. Now, for a moment, P had a memory address in here that was pointing to a deleted spot in memory. So the second rule of thumb that you need to get from this is that whenever you call delete, you should always assign P equal to null right afterwards. This will give P a null value, which means that it's no longer pointing to a bad spot in memory, right? So just to recap, whenever you use new, you got to use delete. Whenever you use delete, assign your pointers to null.